So moving on to problem 2, the gap in a spark plug is 0.025 inches. How great a voltage is required to make it spark? So let's remember from the previous problem that the electric field required to generate a spark is 3 times 10 to the 6th in newtons per coulomb. And actually, we can use different units, right? So electric fields can have units of newtons per coulomb, but it can also have units of volts per meter, which we're actually going to want to use those instead, and you'll see why shortly. Of course, if you broke these down into their most basic units, you would find that newtons per coulomb and volts per meter are the same unit, right? That's why we can interchange them. As well, so the distance we're dealing with here is 0.025 inches. So let's go ahead and convert that to SI units. So there are 2.54 centimeters for every 1 inch. And of course, there are, for every 1 meter, 100 centimeters. So this will leave us with our distance in inches, which should come out to be about 6.35 times 10 to the negative 4 meters. Perfect. So the equation we're going to use here is just the electric field is equal to negative the potential difference over the distance. We can rearrange this. We can multiply negative d over to the other side, get the electric potential equal to negative ED. Plugging in, we have negative 3 times 10 to the 6 volts per meter times 6.35 times 10 to the negative 4 meters. And here we have the meters just cancel out. We're left with volts, which is perfect for a potential difference for our voltage. So this should come out to be about negative 1.9 times 10 to the 3 volts, or negative 1.9 kilovolts. And this is a potential difference. We could really actually just drop the negative here, because whether or not the potential difference is going from one place to the other, right? The negative just determines which way from one to the other. And we really care more about the magnitude in this situation. But that is the problem, or the answer to problem 2.